Now I'm going to explain about the structure of glucose molecule. So simply what we say, glucose C6H12O6. Some properties of glucose are explained by the open chain structure. Open chain just we'll see, and some are explained by the closed structure or cyclic structure. And this open chain structure, it is scientifically known as Fischer structure or Fischer projection, and it is given by scientist named Fischer. And the position of the hydroxyl group at the carbon 4 and 5 is toward the right side, and thus it is called as D-glucose. It is called as D-glucose. And so the glucose has been classified in two categories, D-glucose and L-glucose. Like you see on the glucose packet or the glucose drip which is being given to patients, it is written as D-glucose. So D stands for dextro. And dextro means dextro. D means dextro. Rotatory. Dextro rotatory means rotates plane of polarized light towards the right side. So it is the simple meaning of D. Dextro rotate toward this right side. Dextro rotatory. And see how. Now here I have drawn this Fischer projection or Fischer structure for the D-glucose. This is the D or plus glucose structure. This is, and as you know, they are called as polyhydroxyaldehydes or polyhydroxyketones. So see, this is the carbonyl group, one OH, then this other OH, third, fourth, and 5. So it has 5 OH groups. And so this is carbon 1, 2, 3, 4, 5, and 6. So when the carbon 4 and 5 has OH toward the C4, C5 has OH towards right side. So then it is called as D or plus glucose. So this is the way to have the D and L nomenclature. Similarly, there are different ways. You will see in the high classes there is one more, that is R and S nomenclature. So these are different ways to distinguish the different molecules from each other. Now something more about the D and L configuration. Actually, the D and L configuration in reality, there is no relation with the rotation of the right side or toward the left side, but it's one point that differentiates is the position of the carbon. When the position of carbon is at 4 and 5 having OH on the right side, that is said to be dextro or D-glucose. No doubt dextro rotate toward the right side, levo rotate toward the left side, we say, but it is not the truth. It can be matter of coincidence. Now, children, reality is something else. Actually, the D and L form, they have been derived or they have been based on the structure of glyceraldehyde. So here this plus glyceraldehyde, plus formed glyceraldehyde or deformed glyceraldehyde, here it is glyceraldehyde, it is having this OH at the second OH 1, 2, and this is at the right side. So it is said to be the plus. Similarly here minus glyceraldehyde. Glyceraldehyde is an organic molecule. It is here to correlate the DNL forms. So here, if it is the second carbon, it is having this OH at the which side? This at the left side. So it is said to be the minus. Similarly, in glucose, L-glucose, what will be there? The plus 4, the carbon 4 and 5 will have the OH toward the left side. So this is about the DNL form of the glucose. Now we will see about fructose. Now coming to the structure of fructose. So fructose, as you know, carbohydrates are complex polyhydroxyaldehydes or polyhydroxyketones. So this is the ketonic group. The C2, it has this ketonic group. This is ketonic group. And again, 1, 2, 3, 4, 5, 6. So here also the C4 and C5 has OH on right side. So this is, D-fructose configuration. Actually, the fructose have been taken from the furan, organic molecule furan. Similarly, I have compared glucose with what? With glyceraldehyde. So its structure is compared with furan. See how. Now here I have drawn this furan. Furan is the basic way to distinguish the glucose and fructose. So this furan, it has this 1, 2, 3, 4 and 5. It is 5-membered cyclic molecule. It has this oxygen, and so this is a linkage. Here similarly this is ketonic, and here also there is this oxygen, and it is called as, more precisely, glycosidic linkage. Glycosidic linkage between, say this C1 and C5. 1, 2, 3, 4, 5, 6. This is 1, this is 5, so it is there. So this is about the structure of this DNL form. Similarly, in case of this is, what we say, this is the alpha, this is the alpha D fructose. Actually, there are different concepts. There are some of the basic ways in the chain scenario to explain the DNL form and how they have been related. So actually, children, one more point about the chemical properties. So they have aldehyde group, they have ketonic group. So somehow they represent the normal reactions of glucose. Not all, but some reactions are responded. Like they can be oxidized to carboxylic acids, dicarboxylic acids, and so on. If glucose is heated in presence of HI for a very long time period, then glucose and fructose, they have 6 carbons, so they are converted into hexane. A bromine water is poor reducing, so it converts into carbonic acid, this gluconic acid, and so this is all about the structure of glucose and fructose.